Okay, so let's start looking at chapter 6. 6-1 is about the polygon angle sum theorem. So we're getting into polygons now, starting with the angles. Let's work our way through this. Today we are going to talk about interior angles of a polygon, the polygon angle sum theorem, and the exterior angles of a polygon with the exterior angle sum theorem. So we're going to be working a lot with numbers and calculations today. I'm going to put a little color to this. But red and green, it's Christmas time. All right, so we are going to go ahead and work through this one. So the interior angles of a polygon, the angles on the inside of a polygon are called the interior angles, and there's an image here that shows you that there are the same number of interior angles in a polygon as there are sides. So in a pentagon, which has 5 sides, you have 5 interior angles. The polygon angle sum theorem, there's a formula for it, n minus 2 times 180 degrees. The reason for this is because you can split any polygon into triangles, and the number of triangles that you can split it into is 2 less than the number of sides that it has. For instance, a triangle itself is one triangle, and there are 3 sides, so that is still n minus 2, n being the number of sides. 3 minus 2 is 1. You multiply that times 180. And the sum of the interior angles of a triangle is 180. When it comes to a quadrilateral, sorry, that's not straight, you can split it into 2 triangles, and you could split it into a lot more, but we're talking about the smallest number of triangles you could split it into. So again, n minus 2, since this is a 4-sided figure, that would be 4 minus 2, which is 2, times 180. Put the 180s in here. Gives you 360, which is the sum of the interior angles of a quadrilateral. Okay. Go ahead and finish up the notes here for the triangle. The triangle is a 3-sided figure, obviously. 3 minus 2 is 1. Times 180 gives us 180 for the sum of the interior angles of a triangle. We knew that, right? Hope so. Okay, so we are now looking at a pentagon. A pentagon is 5 sides. So for a 5-sided figure, we're going to substitute 5 in. So 5 minus 2 is 3. And 3 times 180. Getting into that part of the drawing pad that seems to want to give me problems. There we go. Okay, so 3 times 180 is 540. So the sum of the interior angles of a pentagon is 540 degrees. Okay? All right, so the reason for that is if you choose any vertex on a pentagon and draw lines to all the other vertices, this line is already here, it's a side of the pentagon, and from that same vertex, draw lines to all of the other vertices. This line's already here because it's one of the sides. Notice that you have split the pentagon into 1, 2, 3 triangles. 3 triangles times 180 degrees is 540 degrees. That's why that formula works. I know I could just give you a formula and tell you to plug in the number of sides, but I think it's important that you understand why that formula works. So there you go. All right, I'm actually going to type this out a little bit because the pen was messing up there. 5 minus 2 times 180. And then here we had 5 minus 2 is 3 times 180. And that gave us 540 degrees for sum of interior angles of a pentagon. Hope that's a little more clear. All right. I'm going to go ahead and save this as I go. All right, so the problem here says what is the sum of the measures of the angles of a hexagon? So 6 sides, you're just going to substitute 6 in here. 6 minus 2 is 4. 4 times 180 is 720. So the sum of the measures of the angles in a hexagon is 720. So you can use this formula to find the measure of one interior angle of a regular polygon if you know the number of sides. For instance, in a triangle, once you have the sum, if you just divide that by the number of sides, then you get one interior angle. 180 divided by 3 gives you 60. So if it's a regular triangle, that means it is an equilateral triangle, and each of the interior angles is 60 degrees. In a regular quadrilateral, that would be a rectangle or square, if you divide 360 by 4, because it's a 4-sided figure, then you get 90, because each interior angle would be 90. And in a pentagon, if you divide 540 by 5, then you get each interior angle of a pentagon, and so on and so forth. Okay, so we are going to employ our calculator here and do some math. Math sounds good. Let's do math. All right. So we're going to practice that here. This problem says, what is the measure of each angle in a regular pentagon? And they went ahead and went through the process that we started up here. So the sum of the interior angles of a pentagon is 540. Then dividing that by 5 gives us 108 for each interior angle. All right, so we're going to practice this a little bit. The polygon angle sum theorems, okay? So the sum of the interior angles of a polygon is simply the number of sides minus 2 times 180. If you just want one interior angle of a regular polygon, then you're going to find the sum, which is the number of sides minus 2 times 180. And then whatever you're going to get, you're going to divide that by the number of sides, okay? So this actually looks better if we can do this one on top of the other. Maybe I can do that. Can I underline this? I don't know. I can. Okay. And I don't want to underline anymore. Oh, I took it all away. So I want that underlined. And then I want to just put, I don't want that underlined. That's not going to let me separate that here. Okay. All right, sorry I'm messing that up. I'll tell you what, I'll just draw it in. So n minus 2 times 180 is going to give us the sum of the interior angles, and then I'll just divide that by the number of angles, or the number of sides. Okay? All right, so let's go ahead and make sure that we know how many sides each of these figures has. Quadrilateral, hopefully we are understanding that that is 4 sides. 4 sides. I'm going to start typing this too. Be quicker and less messy. An octagon, hopefully we know that that has 8 sides. 8 sides. An 18gon has 18 sides. 28gon has 28 sides. 12gon has 12 sides. A decagon, do you guys know this one? A decagon has 10 sides. Okay. All right, so I'm going to switch colors so we can do the actual math here, and we don't want that to get in the way of the work that we've already done. We're going to stick with the Christmas theme here. So for a 4-sided quadrilateral, we're going to say 4 minus 2 times 180, which is 2 times 180, equals 2 times 180, which equals 360 degrees. And again, we are just finding the sum of the interior angles of each polygon here. Okay, I'm going to do the odds in red, then I'll go back and do the evens in a different color, just so they don't run together. So for an 18gon, I'll have 18 minus 2 times 180, which is 16 times 180, which is 16 times 180, gives us 2,880 degrees. And that is the sum of the interior angles of an 18gon. Let's go ahead and do 5 down here. 12-sided figure, we have 12 minus 2 times 180, which is 10 times 180, which is 1,800 degrees. Sum of the interior angles of a 12gon. All right, let's choose another Christmassy color. Let's go with purple. Okay, so in an octagon, we have 8 sides, so 8 minus 2 times 180 equals 6 times 180, which equals 1,080 degrees. Okay. So for a decagon, 10 minus 2 times 180 equals 8 times 180, which gives us 1440. Oops, not 1449. You guys know that. Okay. And for a 28gon, we have 28 minus 2 times 180, which is 26 times 180, 26 times 180 gives us 4,680 degrees. All right, so if we then wanted to find just one angle, then we would just divide that by the number of sides. So the decagon, we can see the work from number 4 on this one and see that 1440 was the n minus 2 times 180. So we're going to take that 1440, we're going to divide that by the number of sides, which is 10. So that's going to give us 144 is this one angle, one of the interior angles of a regular decagon. Notice I'm saying regular decagon, meaning that all the sides and angles are equal to each other, okay? So for a 16gon, we did not already have the, I'm again doing the odds. We did not already have the n minus 2 times 180, so let's do that first. And we can do it all at the same time here. So we have 16 minus 2 times 180, and then we are going to divide that by 16, okay? I'm going to freehand this so that I don't have to try to botch this up like I did on that other one. We're going to divide that by 16, okay? So we're going to do 14 times 180, and whatever we get, we'll divide that by 16. So here we're just doing the math. 14 times 180, 14 times 180 gives us 2,520, 2,520. We divide that by 16. Okay, and whatever we get for that, we'll put that angle down here as our final answer. Divided by 16. It gives us 157.5. It's 157.5. 157.5 degrees. Okay. All right. So we did not have any of the other ones down here already done either. So let's look at working those out. Okay. So for the 32gon, I'm going to have 32 minus 2 times 180, and then I'm going to divide that by 32. So I'm going to divide that by 32. So we're going to start out with a pretty big number here because we're starting out with 30 times 180. And then whatever we get for that, we will divide that by 32. And close that parentheses. Okay, so 30 times 180 gives us 5,400. 5,400. We're going to divide that by 32, which is going to give us, and I'm going to put the answer down here. I'll type it out. It's a little bit more clear for you to read. Divided by 32. That gives us each interior angle of a 32gon is 168.75 degrees. Okay. All right, so I'm going to go back to red to do the even problems in this section right here. Okay. All right, so for a 12gon, we did find out in number 5 that the sum of the interior angles is 1,800 degrees. So we're simply going to divide that by the number of sides, which in this case is 12. Okay, so 1,800 divided by 12 gives us 150 degrees for each interior angle of a regular 12gon. All right, so I'm going to set up, and I think I'm going to type out a little bit more of this. On 24, or for number 10 for a 24gon, I've got 24 minus 2 times 180, and that's going to give me the sum of the interior angles. I am now wondering if I can underline this and then just go somewhere else with it. I don't know what it's doing. No, all right. So let's stop trying that. Okay, so we're going to divide that by 24. Okay, and we're going to end up with 24 minus 2 is 22 times 180. And we'll divide that by 24. And then we'll show that step right there. Okay, so I'm trying to give enough space here to where I can type all of this in. Let's see, 22 times 180 gives us 3,960. Okay, so I'm going to freehand now. So 24 minus 2 times 180 gives me the sum of the interior angles of a 24gon. Then I will divide that by 24 to get just one of them. So dividing this by 24 to get just one of the interior angles of a 24gon. So 3,960 divided by 24 is what will give me just one of those angles. Okay, I'll write that answer up here, or type that answer up here. Equals divided by 24, which gives me 165, an even number. Well, a non-decimal number, a whole number, not even. It's odd, but 165 degrees. Okay, same exact process for 12 also, except now we have 90 minus 2. So 90 minus 2 times 180. We're going to divide that by 90. So 90 minus 2 is 88 times 180, and we'll divide that by 90. So we have 88 times 180 is 15,840. And then, of course, we will divide that by 90. Okay, so each time here we are dividing the sum of the interior angles by the number of sides to get just one of those interior angles. Dividing this by the number of sides to get just one interior angle. So we are dividing 15,840 by 90 to get just one interior angle of a 90gon. Okay, divided by 90. And again, we get a whole number, which is fantastic. Okay, so that's going to give us 176 degrees. Okay, so this will be a very calculator-intensive section. All right, so exterior angles. The exterior angles of a polygon are those formed by extending the sides. There is one exterior angle at each vertex. The sum of the measures of the exterior angles of any polygon is 360. Okay, so a pentagon has 5 exterior angles, so the sum of the measures of the exterior angles is always 360. So we just need to divide that by 5 to find one exterior angle, which is 72. You also may notice that the exterior angle and the interior angle make a straight line. Okay, let me see if I can show that here. The exterior angle and the interior angle. Here's an exterior angle and an interior angle together, forming a straight line. So if you find an exterior angle, then you can just subtract from 180 to get one interior angle. You might find that that's a little bit quicker than going through this process that we went through on 7 through 12. Okay, so they got 72 here simply by saying 360 divided by 5. I wish they had shown that here, so I'll just show it so you have it on your notes. I hope that you are taking good notes. Okay, all right, so looking down here at the last exercises in this lesson, this is find the measure of n exterior angle for each regular polygon. All we're doing here is taking 360 and dividing it by the number of sides. Okay, so all we're doing here is taking 360 and dividing it by the number of sides. Okay, so it's round to the nearest tenth if necessary, or we could just write the actual answer. Okay, so for an octagon, which is an 8-sided figure, we will take 360 and we will divide that by 8. For a 24-sided figure, we will take 360 and we'll divide it by 24. 34, 360 divided by 34. Decagon, 360 divided by 10. Heptagon, you guys know what a heptagon is? Heptagon is a 7-sided figure. Some texts call it a septagon. A heptagon, 360 divided by 7. A hexagon, 360 divided by 6. You should know some of these automatically. 360 divided by 30 for the 30gon. 360 divided by 28 for the 28gon. And 360 divided by 36 for the 36gon. Okay? So we can do the math on all of these. I should have put equal signs after all these already. That's okay. So 360 divided by 8 gives us 45 for number 13. And this is the degree measure of one exterior angle. 45 degrees. Okay. So for number 14, we have 360 divided by 24, which gives us 15 degrees. Okay. Notice that the greater number of sides, the smaller the exterior angle, because the bigger the interior angle. The greater the number of sides, the more and more your polygon's going to look like a circle, okay? So that degree measure gets closer and closer to 180, which would be a straight line, which is not going to happen, but it gets closer and closer to it. All right, so for 15, we have 360 divided by, 360 divided by 34. And we have our first decimal. Okay, it says round to the nearest tenth if necessary. So this would be, it's actually 10.588235. I don't know if it actually ends up being a repeating decimal or not, but rounded to the nearest tenth is 10.6. Okay, 360 divided by 10 is just 36 degrees. Okay, 360 divided by 7. I hope that y'all are listening to this and not just muting it and watching it on fast forward, because there's a lot that I'm saying that's good information and you can really learn from it. So I do hope that you are watching and listening, not just watching. 360 divided by 7 is 51.4285714. Okay, that looks like it might repeat. So we're going to round to the nearest tenth, which will be 51.4 degrees. Okay. The hexagon, 360 divided by 6. 360 divided by 6 is just going to give us 60 degrees. I hope y'all could do that in your head. Okay. 360 divided by 30. 360 divided by 30 gives us 12 degrees. 12 degrees. Okay. The next one you probably can't do in your head. Well, you might be able to. Divided by 28. Oh, no, you can't. This one is 12.857142, and then it repeats. So rounded to the nearest tenth is going to be 12.9. Okay, and then 360 divided by 36. 360 divided by 36 is going to give us 10 degrees. Okay, all right, so 22, the last problem on this lesson here, wants you to draw a diagram. A triangle has two congruent angles and an exterior angle that measures 140 degrees. So let's give this a draw here. A triangle has two congruent angles. So we're talking about an isosceles triangle here, right? So if the extended angle that they're talking about is an extension of one of the congruent angles, is 140, then that is going to be one situation. It says find two possible sets of angle measures. The other situation here is if you were looking at this situation where you still have the same isosceles triangle, but the extended exterior angle comes off of the vertex angle, not off of one of the base angles. Then we need to look at how to do the math on this. Okay, so I'm going to switch colors to do that math. I don't have much time here. I have 4 minutes before I have to vacate this room, so I will hurry, okay? So in this first one, 180 minus 140 is 40, so my base angles are going to be 40 because the base angles are the same. 40 and 40 is 80. 80 from 180 is 100. So there is one possible set of angles that would work there. In the second situation, the vertex angle would be 40. Okay. 40 from 180 is 140 divided by 2, which would make my base angle 70. So this is the other set of angles that would work for this. Okay. So these angles are 70, 70, and 40. And these angles are 40, 40, and 100. Two different situations there. I hope this has been helpful. Please make sure you take the notes, and you will get a grade for that. In class will get a grade for that. Virtual, you will use that. Okay? Thank you for watching.